class or struct templates may be used as types for function formal parameters, and they may also be used as types for function template formal parameters. In this example, I have a pair struct template. Both members in the pair is going to be of the same type because I only have one type parameter. Then to demonstrate that we can use a class or struct template as a type for function formal parameters, I have this function smallest member, which will return the smallest member in a pair. As you can see, we have the formal parameter right here. It is a reference to a pair template constant with an integer default type argument because we are going to return an integer from this function. The formal parameter is called pair p for pair parameter. So I do pair parameter first. If that is less than pair parameter dot second, then return pair parameter dot first, otherwise return pair parameter dot second. Remember, this is a struct and those members are public. In main, I construct a pair from this template and I pass in int for the type argument, and I initialize the members first to 33 and second to 11, and then I do console output smallest member pair. Okay, so I simply pass that in here. If I left click to place the caret between the parentheses and I do Control Shift spacebar, I can see the function declaration or the header. It returns an integer and it takes in a reference to a pair template constant with an integer as a default type argument. If I build and run this, it prints out 11. I'll change the second argument here to 55, so second will now be 55. Build and run again, and we get 33. Of course, 33 will be smaller than 55. If I change this to a short or to a float, then this won't work. No suitable user-defined conversion from pair float to pair of type int exists. And so if you build, you'll get an error. So how can we change this function to work with this particular pair? Well, we could change this here to float and this here to float as well. That's a type argument. But again, we want our code to be more generalized or abstract. So what we can do instead is we can make this smallest member function a template. As an exercise for you, turn the smallest member function into a template function so that it will work with any pair that we pass in, regardless of the type argument that we specify, where we construct a pair. Okay, let's go and turn the smallest member function into a template. Really simple, we have the template prefix. Instead of returning int or float or something, it's going to return that type. And also, instead of providing a particular type argument, we use t here instead. And if I build a run, this works fine. Okay, just testing both ways, and that works fine. Okay, so quite a few things in this example. You can use a class template as a formal parameter within a function. And to make your code even more abstract or generalized, you can even use a class template as a formal parameter within a function template, as we have it here. Then a few more things to take away from this example. We can pass this in as a reference, so this pair parameter here is a reference. So we're not passing this pair here by value, we are passing by reference. And it's a reference to a constant. So if you try and make a change to the state of the object that we pass in, if we Control F5 to build and run, we'll get an error. Cannot be modified because it is accessed through a const object. So again, the stuff that applies to your regular classes or structs as formal parameters will apply to your class or struct templates as parameters as well. You can pass by value, you can pass by reference, and even by pointer. So we can do pointer here as well. This parameter is now a pointer to a pair template constant. And of course, now I'll have to make a few modifications. So I'll have to pass in the address of that pair right here. And if we build right now, we'll get an error. And it will actually try and help you. Did you intend to use the arrow operator instead? And you can do something like that. And build a run, and that works fine. So you can pass by pointer, you can pass by reference, or you can pass by a value. Next, I still have this pair struct template, and I have this smallest member function as well, but I've added this add members function, which as a formal parameter also has a reference to a pair template constant, Okay, so I pass in t, and this is going to return t, and all I do in the body is I return the pair parameter dot first plus the pair parameter dot second. Okay, so we are going to add those members together. In the main function I construct pair. I don't have a constructor, so I just pass in 33 and 11 using list initialization as in the previous example, and I specify integer as a type argument, and then I can do console output smallest member and I pass in pair, and also console output add members, and I pass in the pair object into that as well. If we build a run, we get 11 and 44. The smallest of those two is going to be 11, and if you add those two together, it's going to give us 44. What happens if you specify some other type here? So instead of integer or float, let's say we have some entity, maybe a vector, or maybe another pair. So for example, you can do something like this, and you can already see some squigglies that the operator is not overloaded. The operand types here are standard OStream for output stream, and the pair template with an integer type argument, and the same for this add members function, and the reason is both of these functions return t. And in the add members function we have this right here as well. So we do the plus operator, the addition operator. So let's say we want a pair of vectors or a pair of pairs, some pair that takes in some class or struct right here, that a particular type, some entity. Then once more you need to ensure that the appropriate operators are overloaded. Undo a couple of times, and that is going to bring me to the next example. Moving on to this next example, I have the pair struct template. I still have members first and second, but then I have overloaded the addition operator, so operator plus, and this is going to return a type of pair. The formal parameter is going to be a reference to a pair constant, and what we're going to do in here is we are going to return a pair, and I use list initialization again, and I simply do first plus other dot first, and then second plus other dot second. And we're going to use that overloaded operator later on. We're going to use it here. So just to keep it concise, I only have the add members function for this example. I've removed the smallest member function from the previous example, but notice we have a precondition. In the previous subsection I talked about what do you think will happen when we create a pair of something other than the fundamental types, so when we pass in custom types such as some entity, a vector, or even a pair. Well, in that case, as a precondition, the operator plus, the addition operator, must be overloaded for the type argument. So again, if the type argument is some entity or a vector or a player character, whatever custom type you might have, then you're going to need to overload this operator because we use it right here. We do pair parameter dot first plus pair parameter dot second. If I scroll up here, remember with this pair, this is a template. First and second are of type t. So let's say you have a pair of vectors, then first and second will be of type vector, or first and second can be of type entity, or whatever type it is that you pass in as a type argument. Similarly, you can pass in a pair, the pair template, you can pass that in as a type argument. In other words, first can be of type pair struct template, and second can also be of type pair struct template. Okay, so that makes this a bit more complicated. And of course, because this add members template function is going to return that type, lets you do a console output statement such as right here we do cout add members and we do a pair of members. I'll get back to that here shortly. Then you want to overload the stream insertion operator, so that's what I did right here. Now because this is a struct, I did not make this a friend. We don't need to make it a friend in this case. This again is going to return a reference to OStream for output stream. We overload the operator, the stream insertion operator, and notice that this is actually also a template. Okay, so we do the template prefix, and for the first parameter we have output, which is going to be a reference to an output stream, and for the second formal parameter we are going to have a reference to a pair struct template constant. Okay, and we pass in t for the type parameter. This is called pair p, and then I simply do output. So what do I want to put out to the output stream? I'll just print something out like first, and then I'll do the pair parameter dot first, and then I'll do second and pair parameter dot second, and we return that output back again. So again, this is a bit more of a complicated example. There's a bit of a back and forth here. Of course, if you take it step by step in this way, you'll see it's not that difficult. So back in main, I have two pairs. I construct pair 1, which will have an integer as a type argument, and I construct pair 2, which will also have an integer as a type argument. Because I don't have a constructor, I'll just use list initialization to initialize those two objects. This is the more complicated part right here. So I have a pair, and this is going to be called pair of pairs because we pass in this type. So the type argument is not an integer, it is not a double or a float, or even an entity or something like a vector. It is actually a template. Okay, so it's the pair struct template, and I pass an integer for that for the type argument. So again, what does that mean? That means this type parameter t is going to accept that pair struct template, and therefore first and second is going to be of type pair struct template with an integer as a type argument. Once more, I use list initialization to initialize that, and I pass in pair 1 and pair 2, and then I do add members and I pass in a pair of pairs. I'll just build around this, and it will print out first is 10, second is 10. I'll change the numbers around a bit and build a run, and we should now get 15 and 20. Yeah. Of course, you can do a few tests. I did not spend a lot of time debugging this program. This is just a quick example for you, just to show you that templates can get really complicated and that you can do some really interesting stuff with it. And you need to think of this entire thing as a type, where we previously had an entity or a vector or something like that. We are now working with templates. And just like the non-template types, your struct and class templates can also be used as types, as you can see right here. And as we've seen here, for example, with functions in your formal parameters, you can have functions with formal parameters that are references to struct or class templates as well. Okay, so I hope you found this section interesting and that this demonstration was not too complicated.